Good morning, children. So this is the first class for class 9, that is Physics Motion chapter. And it becomes a very easy chapter for you. The reason is simple. You have already studied most of the things in class 8. Just recall what you have studied about motion in class 8. You have studied first important thing, the difference between rest and motion. What is rest and what is motion? Now what you are taking at home is rest. Gradually taking rest, you get rest. As you know, so you should not take rest. Be very active. That's why the chapter heading is motion, not rest. That means everything should be in motion. Just recall what I was telling you. Stavarakkali untu Jangamakkali villa. That means what? If something is moving, then it will not perish. If something is not moving, it will perish soon. So in motion, there are different types of motion. Rectilinear motion, motion along a straight line. Curvilinear motion, motion along the curved path. Periodic motion, the motion which is repeating at regular intervals. Oscillatory motion, like the motion of a simple pendulum. Circulatory motion, as the wheels rotate. Translatory motion, which is changing continuously. That means we know these all things about motion. We know clearly about the rest and motion also. Gradually, with these slides, we'll try to recall what you have studied in class 8 and what else we can study in the class 9. So, all the best for all of you.
When we move from one place to another, the measure of total length we cover is called the distance. So you have to travel to this town and the best route is straight up north. But because of roadworks along the way, we have to take a detour and the distance covered would be something like this. Now when the roadworks are completed, the distance needed to be covered would be something like this. Distance is measured in meters and denoted as lowercase m. The distance between these two towns is about 20,000 meters, but because of the detour, you had to cover a distance of 50,000 meters. Okay, so nobody likes big numbers unless it's your salary. So we should also know that a kilometer is 1,000 meters. In our example, we can say that instead of 20 kilometers, you traveled 50 kilometers. Is distance a scalar or a vector quantity? Think about it. If you say someone traveled 20 kilometers from this point, we can't really tell where they landed up. Maybe here, maybe there, or maybe they just went around in circles. As it does not specify a direction, it is a scalar quantity. That brings us to displacement. So what is displacement? Distance with direction is displacement. Distance with direction? What do we mean by that? You made 2 separate trips to this town. Was the distance covered in both the cases the same? Have a good look. It wasn't. In each of the 2 cases, the distance was different. The time you took for the detour was greater than the time you could go straight across. But if you call someone to tell them where you are, in both the cases, your location is this town, which is 20 kilometers north of your home. The displacement in both the cases is the same. You traveled 20 kilometers north. North shows the direction, and because direction is specified, displacement becomes a vector quantity. Now let's look at this example where a mother asks her son to quietly stay where he is while she takes a quick nap. So now the child runs back and forth many times and returns to the original spot before the mum wakes up. The mum wakes up and sees the child in the same spot, and as she hasn't observed what happened in the last few minutes, she assumes the child has not moved. The child, being the future expert in physics, has in fact disobeyed her instruction and covered lots of distance. But at the same time, he can argue that he did follow his mum's instruction. Lots of distance covered, but zero displacement. If the distance travelled is a straight line, the displacement will be the same magnitude as the distance, but with the direction provided as well. In most cases in our day-to-day lives, the distance covered is greater than the displacement seen. Running errands and travelling back and forth between places cause the amount of distance to build up, though you may not end up very far from home. If you've really understood the difference between distance and displacement, you should be able to answer the next question. When a passenger travels by taxi, is he charged based on the distance or displacement? Taxis charge passengers based on distance. If you go to the neighboring town and return in the same taxi, the taxi meter shows you the charge for the entire round trip. If you now try to explain to the taxi driver that you have had no resultant change in your location and hence you must pay nothing, it will not impress him much.
In this slide, I have a video just to make you recall the difference between distance and displacement. Watch the video, enjoy, and try to understand and recall what is distance and what is displacement. Here I have listed out the differences between distance and displacement. Distance is a scalar quantity, whereas displacement is a vector quantity, Distance moved by an object is the actual length of path covered, that means how much you cover. But displacement becomes the shortest distance between any 2 points in a particular direction. Distance covered by a moving body will never be zero. When you cover some distance, it will not be zero distance you have covered. But displacement can be zero when starting point and end point are same. Displacement can be negative also, it can be positive also. Distance is a physical quantity which is measured only by magnitude or size. But to express displacement, we need to have size as well as the direction. These are the differences between distance and displacement.
Uniform motion and non-uniform motion. A body is said to be in uniform motion if it travels equal distances in equal intervals of time. A body is said to have non-uniform motion if it travels unequal distances in equal intervals of time. For example, consider a car moves from one position to another position about 16 meters distance within time t 8 seconds. Here, the car starts from O and after 2 seconds, it reaches position A covering a distance of 4 meters from the origin as shown. In next 2 seconds, it reaches position B covering a distance of 8 meters from origin, and in next 2 seconds, it reaches C covering a distance of 12 meters from origin, and in next 2 seconds, it reaches D covering a distance of 16 meters from origin. In this case, the car covers a total distance of 16 meters in 8 seconds with equal intervals of 2 seconds. It means that the distance covered by the car is directly proportional to the time. From this illustration, we can conclude that the car had travelled equal distances in equal intervals of time. So, this type of motion is known as uniform motion. Another example. Consider a car moves from one position to another position about 16 meters distance within time t 8 seconds. Here, the car starts from O and after 2 seconds it reaches position A covering a distance of 2 meters from the origin as shown. It reaches position B covering a distance of 8 meters from origin, and in next 2 seconds it reaches C covering a distance of 10 meters from origin, and in next 2 seconds it reaches D covering a distance of 16 meters from origin. In this case, The car covers a distance of 16 meters in each 2-second interval. From this illustration, we can conclude that the car had travelled unequal distances in equal intervals of time. So, this type of motion is called as non-uniform motion.
Here we are discussing about the differences between uniform and non-uniform motion. Again, these also you have studied in class 8. Uniform motion, if a body covers equal distance in equal intervals of time, we say it is in uniform motion. If a body covers unequal distance in equal intervals of time, it is said to have non-uniform motion. Watch the video for better understanding. Here is a comparison about speed and velocity. Just when you cover some distance in certain time, that means you are said to have some speed. The speed is a scalar quantity, but if speed has direction, it becomes velocity. So velocity is a vector quantity. Speed is a distance covered by time. Velocity is a displacement by time. Then what is average speed? In day-to-day life, we never talk of speed in actual. We talk of only average speed. That is a total distance covered by total time taken. Then average velocity is total displacement by total time taken. Just imagine here also, average velocity can be 0, but average speed cannot be 0. SI unit of speed or velocity is always meter per second. Speed of a moving body will never be 0. So these are the differences between speed and velocity.
How do we know whether an object in motion is traveling faster or slower than another object? Consider two objects, Object 1 and Object 2, both moving along the same path. Just by looking at their motion, can you tell me which one of them is moving faster? Clearly, this one is moving faster. In comparison to Object 1, Object 2 keeps lagging behind. Hence, we say that the speed of Object 1 is more than the speed of Object 2. Speed is that physical quantity which tells us how fast something is moving. How do we define it? In order to know the speed of an object, there are just two things we need to know. First, the distance traveled by an object in motion, and second, the time it takes to complete that distance. Consider a car moving on a straight road. First of all, can you tell the type of motion it's undergoing? Since it's moving in a straight line, it's in a rectilinear motion. Suppose the time it takes to reach the other side is 30 seconds. Now consider another car which is similar to the first one. It's also moving in a straight line path adjacent to the first one. The time taken by this red car to cover the same length of the road is 40 seconds. The blue car covered the path length in 30 seconds, while the red car covered the same path length in 40 seconds. Which one of them was moving with greater speed? By intuition, we can say that the blue-colored car was traveling at a greater speed than the red one. Why? Because the blue car covered the same distance in lesser time. Let the length of this path be 420 meters. This path length is nothing but the distance that the car travels in a given amount of time. Now for each object, if we take the ratio of the total distance covered and the time required to cover that distance, we will get this. This ratio is called the speed of the object. Yes, speed is distance over time. Since this ratio is greater than this one, it means that the blue car traveled with greater speed. Let's bring in a third car which covers the same distance in 20 seconds. So what is its speed then? The speed is 420 meters over 20 seconds, which will give us 21 meters per second. And you can see that this ratio is the greatest of all. Now I want you to look at the units. Meters per second is one of the units of speed. There are many such units of speed that you must be aware of. For example, kilometers per hour, miles per hour, feet per minute, and so on. We will discuss more about these units in our future videos. Let's discuss something interesting now. Look at the example of one of the cars. Say car A. The only information I gave you was that it covers 420 meters in 30 seconds. That gave us the speed as 14 meters per second. I want you to answer the next question I'm asking you. In this example, can we say that the speed of the car A is constant throughout this distance? Are we saying that the car is covering 14 meters every second throughout the path? No, that's not what we're implying. Because maybe the car is moving at a really fast speed initially and then it slows down in the middle and then stops and then again speeds up. So this speed does not imply that the speed is constant at 14 meters per second throughout. So what is the speed then? The speed we calculated here is the average speed. In fact, in all the three examples, it was average speed. How do we define it? Average speed is defined as the total distance traveled by an object divided by the total time taken. We will continue to discuss more about average speed in our next video.
This slide is meant for making you more clear about the speed of an object, how speed varies or the velocity varies if you know the direction. Now it is a time for homework. Anyhow, you are at home. Now read your textbook from page 98 to 101. Give two examples of objects at rest as well as at motion. Distinguish between speed and velocity in your own words. Fourth question is, an object starts from point A and reach point B, which is 4 cm away from A. Again it returns back to point A. Find the total distance covered and displacement. If it takes 2 minutes for its total journey, find average speed. Then try to answer textbook questions of page 100 and 102. Then you try to search out what is instantaneous velocity. When you read the textbook, you get the answer.